Okay, you guys, so let's go ahead and do another round of these types of problems. Again, overall, we're still being asked to find the 6 trig function values, right? And so I'm only going to find the 3, the big ones, sine, cosine, and tangent, with the idea that you can find the other 3 with reciprocal or not. But the information that's given is a little more challenging. In the problems up above, I gave you exactly what you needed, right? I gave you an ordered pair. You were able to find R. We were able to draw a picture, right? And it was pretty much cut and paste, if you would, or just substitute. But here what I'm doing is I'm giving you different information. So it's up to us to find what we need. And so like I said, classic math problem. I'm going to give you some information, right? And then you have to come to some conclusions and build off of that, just like you did in your, I think it was our abstract function review. So again, kind of an abstract problem because we're not given exactly what we need. We got to put our thinking caps on. So at any rate, number 5 says that the terminal side of an angle theta is given by the equation x minus y equals 0, where x is less than or equal to 0, right? Use this information to draw the smallest positive angle in standard position. All right, so let's go ahead and do that first, all right, and then we can build from there. So what's happened here is the terminal side of the angle we're considering actually coincides with the line x minus y equals 0. So let's do a little bit of scratch work over here. If we move the y over, right, we're basically talking about the line y equals x. And so, you know, again, or if you use ordered pairs, if we drew a picture of this, right, 0, 0 is on this line, 1, 1 is on that line, 2, 2 is on that line, negative 1, negative 1, negative 2, negative 2. And as I shared with you guys, you can use whatever one you want. So here's the actual picture of the line. And now this gets a little confusing, right? Because if we rotate, right, are we talking about this angle theta here? Or if we rotate, are we talking about that angle there, right? Because there's two angles that would have x minus y equals 0 making its terminal side. And this is where we use this information, right? We were told that x is less than or equal to 0. So that basically rules out that part. So putting that all together, right, the picture of our situation, right, is we actually have our, again, here's the line going through negative 1, right, and negative 2, negative 2. There's basically the line y equals x, where x is less than or equal to 0. So that means my initial side's over here, and we're going to rotate until we get to the line y equals x, where x is less than 0. So there is basically the theta that we're after. And of course you have a lot of data points you can use. How about I just use the nice easy one, negative 1, negative 1. And so now, right, I'm back up to here, right? I now have an ordered pair on the terminal side. I can use that to find my R. Right, and we find that R is equal to the square root of 2. All right, and of course the ordered pair I chose was negative 1, negative 1. If you want, you could use negative 2, negative 2. Right, again, as I shared with you in another video, it doesn't matter which one you use. It's all similar triangle anyways. So we got everything we need, right? So again, x is negative 1, y is negative 1. So what's the sine of the angle that we were able to draw? Well, it's my y coordinate, negative 1, over my r value, which is the square root of 2. And again, rationalizing the denominator, we get that for our sine value. What about our cosine of the angle that we were able to draw? What's the x coordinate, negative 1, over the r value that I created? And again, rationalizing the denominator, we get negative square root of 2 over 2. And then last but not least, right, what's the tangent? Well, the tangent is the y coordinate, negative 1, over the x coordinate, negative 1, which actually gives us an output of 1. And so again, I'm not really interested in what that angle is. I was able to draw a picture of it, right? I was able to find an ordered pair on its terminal side, and because I have all that, my definitions are in play. All right, so again, there's your big 3. I'll let you guys find the secant and the cosecant and the cotangent using those definitions or just considering reciprocals. So let me demonstrate this one more time. All right, so we have the terminal side of an angle theta is given by the equation 2x plus 3y equals 0. This time where x is greater than 0, use this information to draw the smallest positive angle. So let's do that first, right? So let's take our equation, 2x plus 3y equals 0. If we play around with this a little bit, we get that 3y equals negative 2x, divide by 3, and we basically get that y equals negative 2/3 x. So this tells me I've got a line, right? Let's go ahead and consider the entire line, right? I've got a line that basically has the origin as the intercept, and then its slope, we're going to move down 2 and over 3. Or I can move up 2 and back 3. So there's basically the line that's given, right? The 2x plus 3y equals 0 line. Of course, again, you can't really do too much here because there's two potential thetas, right? There's that theta there, or there's that theta there. So let's use some more information, right? They're telling us that our x value has to be bigger than or equal to 0. So that basically rules that out. So when I start looking at my picture, here's the picture that we need, right? My initial side is going to be along the x-axis. My terminal side, right? We just have to basically find an ordered pair. How about I let x equal 3, and that would end up meaning that y is equal to negative 2. So y is negative 2, x is 3, there's my ordered pair. There's the line, right, with that ordered pair on it, and then there's basically my angle theta. Okay, and so we've got basically the picture we need. So x is 3, y is negative 2. Again, how many ordered pairs lie on that line? An infinite. All right, I just picked one. Remember, the reason I chose 3 is because we're dividing by 3. So if x is 3, the 3's cancel out, leaving us with a negative 2. So that's why I chose it. But you could use anything. And so now I have everything I need except for r. So what's r? What's my x-coordinate squared? Oops, my x-coordinate squared. My y-coordinate squared, square root. So we get 9 plus 4. It looks like my r is the square root of 13. Alrighty, and so now what we have, right, is everything we need. So what's the sign? Well, the sign is my y value, negative 2, over my r value, which is the square root of 13. Again, rationalizing the denominator, we get negative 2 square root of 13 all over 13. What about the cosine of this guy? Well, it's the x-coordinate 3 over the r value of the square root of 13. Rationalizing my denominator, we get 3 square roots of 13 over 13. What about the tangent? Well, by definition, the tangent is my y value, negative 2, divided by my x value of 3, and there would be your value of tangent. Of course, what are the other 3? Basically, you can consider their reciprocals, or just go and use the x, y, r definition. But there's the big 3. Okay, so again, a little nuance there. We had to do a little bit of work. Hopefully our review helps us out here, right? We're basically graphing a line, and then when we graph that line, right, we're trying to figure out with other information, where are we at, right? What quadrant are we in? And then I can find an ordered pair on the terminal side, and we're basically back to problems just like this. All right, so as promised, that's my last one. I know you guys see another problem down here, and this is my way of trying to promote some Canvas conversation. All right, so this way I know that you guys are watching my videos and getting to certain points. All right, so you guys, your challenge is to finish the problem number 7, all right, from this thing in Canvas. All right, so let's see what you guys come up with, practice, and that way you're ready for any upcoming quizzes. Thank you for your time, and again, if you have questions, you better ask them.